Okay, we want to solve this trig equation. We have cosine of 2 theta plus 6 sine squared theta. This is equal to 4. What shall we do? First thing we want to notice that this right here is 2 theta, but then here we have a theta. The angles are different. That's no good. We must have all the angles to be the same in a trig equation. Okay, keep that in mind. But then this is 2 theta in cosine. We do have a double angle formula for cosine, right? Which one should we use though? It has 3 versions, right? So the version that I'm going to use right here is that this is the same as 1 minus 2 times sine squared theta. And this is another thing you have to keep in mind. Because you see we have sine squared theta right here already, I want to use the one that has the like term. So I want to use 1 minus 2 sine squared theta, and then once I bring this down, you will see we can combine like terms and everything will go pretty smoothly from there. So keep in mind, all the angles has to be the same, and then ideally speaking, we want to have either all sines or all cosines, things like that. Okay, what can we do right here? To solve a trig equation, we want to isolate the sine cosine part, right? Here we only have the sine squared theta, so let's try to isolate that. And then we see that we have a negative 2 sine squared theta plus 6 sine squared theta. We can combine the terms, right? Negative 2 plus 6 is 4, and then we have the sine squared theta. And what should we do with this one? Let's just minus 1 on both sides. So that this, and that will cancel, and then we'll get 4 sine squared theta equals to 4 minus 1, which is 3. And now what? We do not want to have this 4, and this is 4 times that, so let's divide both sides by 4. So this cancels, and then we have this right here. And then we are talking about sine squared theta is equal to 3 over 4. I want to isolate the sine part, okay, sine theta part. This is sine squared theta, that's no good. Well, we can just take the square root on both sides. And don't forget to attach the plus minus on the number side right here. So, square root cancels. We have 2 things to consider. This right here, let me just write it down. I'm going to first worry about sine theta, okay? And I want to look at the positive version first. Positive square root of 3 on the top over, we will also square root the 4 on the bottom, which is just a 2 on the bottom right. And then we also have the negative version right here, and let me just write it down. But then we'll focus on that, okay? Negative square root of 3, 2. Okay, so sine theta, sine of what angle is equal to square root of 3 over 2? You have 2 ways to do it. One, you just memorize all the numbers, all the angles on the unit circle, and then you just tell me the answers and the answers. But I would not recommend you to do that. This is how you can figure out like how to get the angle right here. The only 2 things that you have to remember is the special right triangles and the ratio of the sides. That's all. And here we go. So we are going to start off with x and y coordinate plane right here. And then you have to remember for sine is what? Sine by definition is the y over r when we're talking about the xy plane, right? So by looking at this equation here, we know that y value is square root of 3 and it's positive. So that means I can just kind of draw like a positive square root of 3 somewhere, and that means I have to go above the x-axis. I can just draw right here. This is my square root of 3. How is that? What does r mean? R is the radius, but then in this situation, when we're talking about triangles, it's the hypotenuse, right? So r is this, and this r is always positive, by the way, okay? Just a quick remark. The y value can sometimes be negative or positive, but then the bottom is always positive for r. Anyways, r is 2, that means I can label this right here to be 2. And now what? You see, we have square root of 3 and 2. What should this side be? This should be 1, isn't it? And now, when you have this picture right here, all we have to do is figure out what this angle is. And all we have to do is figure out this angle by remember the special right triangle. This is going to be a 30, 60, 90 special right triangle. Well, this is 1, that means this has to be 30 degrees, the smallest angle. So that means this has to be 60 degrees, right? But then we are going to write the answers in terms of radians. So the 60 degrees here is what? Pi over 3 radians, right? Which is the same as 60 degrees. But then, do we have another choice for the positive y value? Yes, because right here, this is positive square root of 3, right? However, on the other side, this y value is also positive. As long as we go above the x-axis, we can also draw this to be square root of 3. And then, as I said, the r is always positive, and that's the hypotenuse. So you have it like this, right? And once again, you can draw a right triangle this way. But this time, this side here is technically -1. However, this is how we are going to figure out the other answer. By the way, let me just write down the answer right here. The first answer is pi over 3. We got it right here. Okay? And then this is the second answer from this picture. We know already this is the right triangle that we have. So this is the angle, which is the same as pi over 3, like just like that one. This is not how we count the angle though. What we're going to do is, you start off with the positive x-axis, and then you have to go from here all the way to here, and then figure out how much to return. Well, you have a few ways to do it, up to you. But then the way I will show you is, you know the whole thing here to here is 180 degrees, which is pi. And you know this much right here is pi over 3 already. So the blue one I draw right here, it has to be pi minus pi over 3, right? Pi is what? It's like 1 over 1 pi, right? So this is the same as 3 over 3 pi. 3 over 3 minus 1 over 3 is what? 2 over 3. And then of course we have the pi, and let's put the pi on the top. That's this angle here that I have in blue for you, okay? So I'll put that down right here. This is 2 pi over 3. And then we just have to do the same thing right here. Okay, let's see, what can we do right here? Draw the x and y axis, and then you see that we have the negative version, right? But then I want to put a negative on the top, because by definition of the sign in the xy plane is y over r. R is always positive, so then you always look at the negative on the top. In our situation here, we have negative square root of 3 for the y, and let me just first draw it like this right here. Okay, just I want to do it counterclockwise. This is negative square root of 3, isn't it? The 2 on the bottom is what? It's r. That means it's the hypotenuse right here. And you see, we'll be using pretty much the same angle. You know this right here is going to be pi over 3. However, that's not how we count the angle. How do we do it? You go from here, okay, you go from here, and you count all the way to this side right here. Okay, this side, the hypotenuse. You have to figure how much to return. Okay, on the top, we turned 180 degrees, namely pi radians. But then we go pi over 3 more. So for the red one, we are going to write down pi, right? And then pi over 3 more. So we add it with pi over 3. This is 3 over 3 pi plus 1 over 3 pi, which is going to be 4 pi over 3, isn't it? So that's another answer, 4 pi over 3. Do we have one more? Yes, we do, because negative square root of 3, it can also be down here as well. This is negative square root of 3, and then we have the 2 right here. And then this is still pi over 3, but this time we'll go from here, come all the way to this side in blue. For the blue part, you see the whole thing is 2 pi, right? The whole circle, the whole revolution is 2 pi. 2 pi minus pi over 3. Okay, so this right here, 2 pi is the same as 6 pi over 3 minus 1 pi over 3, right? So if you do the calculations right here, 6 minus 1, that's 5 pi over the same denominator, 3. And then we are done. Pi over 3, 2 pi over 3, 4 pi over 3, and then the last one that we have is 5 pi over 3.